Okay, here is the second part of the video, picking up at problem number 5. Now, this problem's a little tricky because part A doesn't really relate to the picture, but part B does. And so just make sure that part A you can do, and then part B use the picture to help you. So in part A, what it's saying is there is this circle, not the circle that's shown in the picture, so that's kind of why it's weird, like I said. But there is this circle that has a circumference that is 20 pi centimeters, and it wants to know what is the area, and it wants us to leave it in pi form. And so when you're given a circumference, and then they're going to ask you to find area, what we're going to need to do is find the radius, because we can't find area without radius. And so what we're going to do is we're going to take the circumference equation, which is 2 times pi times the radius, and this is for part A. 2 times pi times the radius, the circumference equation, and we're going to set that equal to 20 pi because we know that's what the circumference equals. All right, now this is what we're going to solve. We're going to solve this for r so that we can get a radius, and once we have a radius, we can find an area. All right, and to solve this for r, what we're going to do is we're going to divide both sides by 2 pi so that our pi and our 2's cancel. And if we divide that side by 2 pi, we have to divide this side by 2 pi. And what we end up getting when we do this is that r equals, well, the pi's cancel, and 20 divided by 2 is 10, and so the radius is 10 for this circle in part A. And now if we want to find area of this circle in part A, area is always equal to pi times the radius squared. And I can plug in my radius because I just found out it was 10. And so area equals pi times 10 squared, which gives me an answer to 100 pi. And when it says leave it in pi form, this is what they mean. They want it to be left as 100 pi and not some decimal. All right, and then that's just your answer for part A. We had to find the radius. Again, this was the circumference equation set equal to the circumference they gave us, solved it for the radius, which was 10, and then used the area equation here to find out what the area of that circle was. All right, now we'll move to part B. Part B actually does use this picture here, and it says just to find the area of this shaded region. All right, what I want you to notice is that this 12 centimeters here, that 12 centimeters is really the same as this diameter. The diameter of the circle is also 12 centimeters, which actually means this is a square here because the diameter would also have to be 12 going from top to bottom as well. And so to find the area, we're going to have to find a couple areas here. We're going to find the area of the square, and then we're going to find the area of the circle, and we're going to subtract out the circle. All right, so the first thing is area. Just the area of the square. Area of the square is going to be, when we do area of a rectangle or a square, it's just length times width. And in this case, that is going to be equal to 12 times 12, which means the area of my square is 144. And is there a unit? Yes, centimeters squared. Okay. So now I have the area of my square. I now need to find the area of my circle. All right, area of circle. And area of the circle is going to be kind of like the area, the same as the area formula, 4 pi times the radius squared. But they're telling me in this problem the diameter is 12. The diameter is 12. Well, your radius is always half of your diameter. And so my radius must be 6. And now I can find out what that area of that circle is by plugging 6 in for r. And I get pi times 6 squared, which gives me an answer of 36 pi. Okay? Now, if I want to find the area of the shaded region, well, the shaded region is really just this square minus the circle. And so if I want to find the area of the shaded, what I got to do is I take the area of my square, which was 144, and I subtract out the 36 pi, and I'll be left with the area of my shaded. Now, this is going to be calculator work because there's a pi in here, and what I end up getting is 144 minus 36 pi. I end up getting 30.9 centimeters squared is that answer. That is what is left after you take your square and subtract out your circle. So 30.9 centimeters squared is the area of the shaded region here. Okay, two different part problem. I apologize, kind of a bad problem on my part. A doesn't really do what the picture, B does. Both good problems to practice. A lot of different things. Finding radius when you're given circumference, and finding area when you're given circumference, and then finding kind of that area of a shaded region. We'll move on here. So problem number 6, we need to find the area and perimeter of this sector. Now this is a problem like we saw in 832, where you want to find kind of the portion of the whole thing. So you kind of find like the area of a whole circle, and then find just that portion of it. So actually what I'm going to do to start this problem is I'm going to it's going to look bad, but I'm going to finish that circle. And really what we're looking for is that 120 degree portion of this circle. And we want to find the area and the perimeter. Let's start with area. Okay, so if you can kind of tell here, this is the radius here. That 6 centimeters is the radius, and that's the radius I'm going to use to find the area of my whole circle. And then I'm going to multiply the area of my whole circle by just the portion. So area of the whole circle is going to be pi times the radius squared. My radius is 6, and so my area really equals pi times 6 squared. And the area of the entire circle is 36 pi. Now, that's the area of the whole thing. We just want that kind of shaded part, or just that sector. And so what we do to find that sector is we take the whole area, 36 pi, and we multiply it by the portion, which is 120 degrees out of the 360 degrees, because it's a circle. And then we just multiply this, and we can solve. This is two different ways you could do it. You could just do it as a decimal. I'm going to try to leave it in pi form, because I think the problem says, yeah, leave it in pi form. And so what I do is 36 pi. This fraction actually reduces down to 1/3. And then we can multiply these two together. I'm going to put the 36 pi over 1, multiply the denominators, multiply the numerators. What you get is 36 pi over 3. And 36 pi over 3 should just reduce down to an area of 12 pi. And that should be your answer here for this problem, is that sector has an area of just 12 pi. Okay? So now we want to find the perimeter of that sector. The perimeter of that sector is just this portion. Actually, it's this whole thing. We want to find that. And then we're going to add our 2 radiuses onto it as well. We're going to find that perimeter. The first thing we're going to do is we're going to find this arc length that I'm going to put in blue. And to find this arc length that we're going to put in blue, what we're going to do is we're going to find the circumference of the entire circle, find the circumference of this entire circle, and then just multiply it by the portion that we want, that 120 over 360 again. And so what we get, if we're finding the circumference, is circumference equals 2 times pi times radius. I said already that my radius is 6, and so circumference equals 2 times pi times 6, which tells me my circumference is really going to be 12 pi. All right. 12 pi is my entire circumference. It's all the way around the circle. I just want that blue portion. So what I do is I take my whole circumference, 12 pi, multiply it by the portion, 120 over 360, and solve it. Or actually not solve it, really just multiply it here. 12 pi over 1, multiply denominators, multiply numerators. Sorry, I'm going to reduce this down before I multiply. This is 12 pi over 1 times 1/3 again. Now I'm going to multiply 1 times 3, 12 pi times 1, and I end up getting, this is equal to, sorry, kind of cut that out, 12 pi over 3, and that reduces down to just 4 pi. And that's not my final answer because it wants to know the perimeter of that whole thing. It wants to know, I'll put it all in blue. It wants 4 pi is just this blue portion right here. That's 4 pi. I have to add in this and this, which is 6 centimeters each. And so what I have to do to my answer here, I have 4, I'm going to go back to black here. I have 4 pi from the arc, but then I have to add in the 2 radiuses, which was 6 and 6. And this is going to give me a final answer of 4 pi plus 12 centimeters. Now, if you don't like that answer because it's got a pi and a 12 in it, I don't mind if you put this. The only reason I'm leaving it like that is because it says to leave it in pi form. Now, when it looks like this, you could leave it in this kind of form. That doesn't bother me. Or you could actually, I know even it says pi form, you could do 4 pi plus 12. And if you came up with an answer of 20, sorry, that's not 20. If you came up with an answer of 24.57 centimeters, that would be okay with me too. But those are the 2 answers here for 6, your area being 12 pi, and then your perimeter being either 4 pi plus 12, or if you calculate that out, 24.57 centimeters. All right. This last problem here, 7a and 7b, it's doing the same thing, but just doing it 2 different ways. And so the first part is we want to find the sum of the interior angles of a regular dodecagon, a 12-sided shape, and we want to use the Vertice Break method. And I'm going to try to do my best here. See if I can zoom in a little bit to actually show you the break. I don't think I can on my Smart Notebook file. But the idea behind a vertice break is you pick the vertice that you want to break from, and then you draw lines to all the other vertices. And so you go this vertice over to here, to here. This is going to look terrible because I'm on my computer here. But you break it by the vertice here. Okay? And then what you get, and this is the idea here, that when you do a vertice break method, the triangles that I'm creating here by breaking it, there's always 2 less triangles than the number of sides. And so if I'm doing the vertice break here, that leads me to this idea that there are 2 less triangles, n minus 2 less triangles than the number of sides, and each triangle has 180 degrees in them. So if I want to find the sum of the interior angles using the vertice break method, this is the equation I use, is the n minus 2 times 180, because there's always 2 less triangles in here than there are number of sides, and each triangle has 180 degrees in them. Okay? Now, when I calculate this out, this is a 12-sided shape, and so I need to plug in 12 for n, which gives me 12 minus 2 times 180, and that gives me 10 times 180, and 10 times 180 gives me 1,800 degrees is the sum of all the interior angles using the vertice break method here. I will do this one quickly here because I don't want to go to another video. This is the sum of the interior angles using the central break method. The central break method means I'm turning this into triangles based on the center. So it looks something like this. Now, what this has is, instead of doing the n minus 2 triangles, because if you look at this after I'm done doing it, there is actually 10 triangles in here. And so what we can do is we can do 10, we can do our number of sides or our number of triangles, n. I want to get rid of that parentheses. Actually, no, what? No, n. And then we multiply that by 180 because there is 180 degrees in each of those triangles. I have 30 seconds left. I'm going to put the rest of this in a third video so that I don't run out of time. It'll probably take 2 minutes, but I apologize. I don't want to run out of time here.